For today's video, we'll be solving the law of mass action expression of NO gas plus Cl2 gas reversible to NOCl gas. The first step is to know their atomic inventory and balance the equation. This is a process that is divided by the product and reactant side. Remember that if you get it wrong, the whole process or the whole expression that will be conducted is also wrong. Now in here, NO has 1 and Cl has 2, and for the product side, we have NO with 1 and Cl has 1. And for us to balance the equation, we need to add 2 as NO's numerical coefficient that would result to NO is equal to 2, Cl is equal to 2, and to balance the product side, we need to add 2 on NOCl. And this would result to NO2 and Cl2. Now, the equation is balanced, we can now proceed to the law of mass action expression. But first, we need to know the equation for the equilibrium constant. K represents the concentration of one of our products, so that's going to be C raised to the power of the number of moles that we have of that chemical. Likewise, the concentration of D raised to the power, and that power is going to be moles of this product as well. Likewise, we're going to put the reactants on the bottom. It's simply the concentration raised to the moles. Meaning to say, the product side would be the numerator and the reactant side would be the denominator. All the capital letters represent each chemical equation, and outside the bracket or the small letters show their numerical coefficient or number of moles. So as we know the equilibrium constant, we can now proceed by substituting the whole equation of the chemicals. So here we have a concentration of NOCl raised to 2 as its numerical coefficient or number of moles, and NO raised to 2 times Cl2 as its denominator. NOCl as for its numerator represent capital C and 2 represent small letter c, and NO as its denominator represents A, and the 2 outside the bracket represent the small letter A. And lastly, Cl2 represent the capital letter B. We're done. So the equilibrium constant expression would be NOCl squared over NO squared times Cl2. Thank you for watching this video.
Now we are proceeding to number 2. We have here the given of CO2 gas plus H2 gas reversible to CO gas plus H2O. Step 1. Balance the equation and know the atomic inventory. So we have here C is equivalent to 1, O is equivalent to 2, and H is equivalent to 2. Reversible to C is equals to 1, and O is equals to 2, and H is equals to 2. So, the equation we have is already balanced. Step 2. For us to substitute the balance equation, we need to write first the equilibrium constant. Since we already balanced the equation, we are now proceeding to step 3 after we write the equilibrium constants. Now it's time to substitute the balanced equation. After we substitute the balanced equation, we are now proceeding. The law of mass action expression is written as the numerator will be the CO and H2O, which is the C and B, and the denominator will be A and B, which is CO2 and H2.
We have a given of SnO2 plus CO yields to Sn plus CO2. First step that we have to do is to balance each sides our reactant side to the product side. And first, we have to list all the elements with a corresponding number of atoms. First, we have Sn with one number of atom, O2C1O1 for our reactant side. And for our product side, we have SN1C1O2. Then the next step we have to do is to find a numerical coefficient that will make our equation balanced. And for the numerical coefficient that we found is, we found the number 2. Then we will have 2 for C, 2 for O, and for our product side we have 2 for C and 4 for O. Then we will have this general equation, and what we will do next is to substitute. Then after we substitute, we will end up with this final equation, and that's our final answer. This is our whole process.